Hi, I'm Dr. T, and welcome to my office. So today I'd like to talk a bit about radiation. In popular parlance, it's usually thought of as radiation as this bad, scary thing. And, well, there are definitely forms of radiation that we need to respect and not go playing around with because they can cause serious damage. However, the term radiation is actually very broad. It's really speaking about the transfer of energy via traveling packets of energy, whether these be wave particles like photons or charged or uncharged particles traveling through space. Now, with these packets of energy, once they arrive, of course, they can do things with that energy. Now, they might be able to excite a few electrons from their ground state to an excited state. That simply falls back down and nothing much happens. That's what we see with visible light. And yes, visible light is a form of radiation. Now, it can actually be dangerous if you get enough of it, see laser, but under most circumstances, we usually don't think of visible light as a particularly dangerous thing because, hey, it doesn't usually cause that much of a problem. Other forms of radiation can cause molecules to vibrate or spin, such as infrared and microwave, respectively. However, some forms of radiation collide with atoms enough that they're able to dislodge electrons. The amount of energy in the energy packet exceeds that of the ionization energy of the atom. And as such, we call that ionizing radiation. This is typically what we're thinking about when we're saying radiation. This is the one that can start creating problems. Although I should point out, ultraviolet light is not particularly well suited for the definition of ionizing radiation, as it does not normally create ions. It can, under certain circumstances, although typically the interaction with ultraviolet light does not actually create an ion. Therefore, it's not ionizing radiation, although it is capable of interacting with chemical bonds in such ways that can create problems, whether it means breaking bonds that we would prefer not to break, or allowing bonds to form that we really didn't want them to form in the first place. But, strictly speaking, ultraviolet light is not under normal circumstances ionizing radiation. It and the higher wavelengths are what we call non-ionizing radiation. They don't make ions. Now, let's look at the ionizing radiation. Once again, this is usually what we're thinking of as the dangerous one, but dangerous versus safe is an unfair dichotomy. And as mentioned earlier, a good old laser can do a lot of damage. So, quantity matters. And when it comes to ionizing radiation, the same story is true. We are exposed to ionizing radiation on a daily basis and a near continuous basis, honestly. Therefore, our cells have the ability to repair damage that may happen from an ionizing radiation particle striking an atom that was rather useful, turning it into an ion and therefore breaking some molecule. That happens. That's normal, and our cells are able to repair that. The problems end up coming in is when the amount of damage starts to exceed the cell's ability to readily repair itself, and at which point either the cell can die if the damage is extreme, or that damage can be incorporated into parts of the cell that lead to other problems, such as damaging the DNA and disabling certain safeguards that prevent the cell from going rogue and making an insane number of copies of itself, and in the process killing the organism for which it's a part of. That long description is basically cancer. So let's actually talk really briefly where you might be experiencing some of your radiation sources. So obviously you walk outside, if it's during the part where the sun is visible and it's bright outside, well, that sun is emitting a ton of radiation. That's why we love it. We love the light and the warmth and the heat. All of that is coming to us via radiation. However, some of the radiation from the sun is coming in high enough energy particles that it is ionizing. And once again, you got the whole UV thing, which is kind of on that border. Not really ionizing, but it's not exactly safe either. This radiation, of course, does hit us, and we do get a fair amount. The atmosphere does stop a lot of this radiation, though, as well as Earth's magnetic field. The nice charged particles get deflected away. If you decide to fly, you are going to be exposed to less atmosphere above you than when you were on the ground, because, you're high up, and therefore you will be exposed to more radiation. That said, we're not exactly talking a ton over here. The rocks and minerals that make up the ground around you, of course, may be containing radioactive nucleuses, and thus those will be getting off radiation. as well as building materials, etc., not to mention the food you eat. Bananas are known for having an inordinately large amount of potassium. Okay, it's not an insane amount of potassium, but they got a fair amount of potassium, and there are radioactive isotopes of potassium. Therefore, when you consume potassium-rich foods, which I may add is essential for your diet, not necessarily bananas, just potassium in general, you are getting exposed to some level of radiation. Once again, in all cases, these are well within your cell's ability to adapt and handle the damage in which those cause. Now, one of the major causes of lung cancer that's not smoking, because smoking is really not good for you, is radon. Radon is a noble gas. It is formed from the radioactive decay of certain isotopes that are found within the minerals below your feet that can then percolate up through the ground into your house and start collecting. If there's too much of this can expose you to radiation, especially exposing you to radiation from within your lungs where there is no protection from the aforementioned radiation, thus leading potentially to lung cancer if your cells are not particularly capable of handling the damage in which they are ensuing. This is therefore recommended if you purchase a house or are going to be living in one for a while to pick up a relatively inexpensive radon test kit, see what the radon environment is in your house, and if it is above safe levels, get that addressed, which is not a cheap fix. But, you know, neither is lung cancer. Lung cancer is not cheap. Foundation work is a lot better than lung cancer. Of course, speaking of medical treatments, medical imaging, as well as certain other therapies, do of course involve the exposure to X-rays and other forms of ionizing radiation. The consciousness of the potential hazards of radiation from medical procedures has become much more in the consciousness of the medical community as time has progressed. If you go back to, say, pre-World War II, really into the 19-teens, very liberal use of X-rays, high doses for applications where we would not even think of using them, like to see if your shoe fit. Take an X-ray of your foot with the shoe on. Yeah, we would not do that anymore. Nowadays we try and limit X-rays, and you will see medical communities going, do we really need the X-ray? Is it going to give us valuable data that is worth the dose in radiation? Of course, this can feel like a, hey, why am I not getting treated as much? But it's like, no, there is a trade-off. It is a very small dose of radiation, but it's still more than what your cells would otherwise be getting on a normal basis. Obviously, for those individuals working with radioactive substances and or with X-ray machines, etc., they need to take precautions, which I will outline in other videos as to how you protect yourself from ionizing radiation. So with all that said, big take-homes. Radiation is a thing. Not all radiation is bad. We like seeing. Seeing involves radiation. It is typically the ionizing radiation that we have to worry about, although non-ionizing radiation, depending on quantity and type, can be an issue as well. When it comes to ionizing radiation, you are going to be exposed to a modest amount of it. Just full hard stop, that will happen. What you don't want to be exposed to is a lot of it. That can lead to significantly more problems. So you want to limit your exposure, but do realize you're not getting to zero, and your cells don't need you get to zero exposure. They just need you to maintain a reasonably low exposure to radiation for them to maintain the repair functions that are essential for them being them. So with that said, have a wonderful day, and I will see you in later videos.